water naturally is corrosive. It doesn't need any help to be corrosive. Is that correct? Like,
yeah, if you
it
want to
doesn't
have
need
some
to be
fun,
bad water. It could be fresh spring water. It doesn't matter.
Well, here's the thing. The more stuff that's dissolved in the water, the less aggressive the water can be. But water is the universal solvent. So given enough, it might take it a little longer to dissolve what it's dissolving, but it will dissolve it. If you want to have some fun at home tonight, put a nail in a glass of water and just watch it over the next week. And after a couple days, it's almost going to be gone.
Okay, welcome to the Engineers HVAC Podcast, where our mission is to empower and educate the HVAC community. This podcast is brought to you by Insight Partners and Hobbs and Associates, two commercial HVAC rep firms. I'm your host, Tony Mormino with Insight Partners, and today we're going to be discussing the importance of cooling tower water treatment and what happens when you don't have good quality cooling tower water treatment. So today I have three very special guests. I'm super excited. I'm going to let them talk a little bit about themselves. So Trace Blackmore, how are you today? Why don't you give the audience a little rundown of who you are and what you do?
Yes, well, first off, super excited to be here. I've been in water treatment since probably I was born. My father was in the industry. My first water treatment memory was burning my hand on his hot plate when I was 5 years old. Probably shouldn't take your kids into service with you. I don't know if that was a bad parenting thing or not, but I learned a lot. And then since that time, I started my own firm here in Atlanta, Georgia. Also started a podcast around industrial water treatment, and I also facilitate a mastermind around water treatment. So everything water treatment in my life.
That's awesome. The podcast is Scaling Up H2O. Is that correct?
That is correct. It's the podcast where we scale up on knowledge so we don't scale up our systems. So It's not just for industrial water treaters. Anything that's helped me run an industrial water treatment company. So we talk about business, we talk about water treatment, you name it, it's on there. If it's helped me, it gets on the podcast.
Excellent. Well, thank you so much for being here. We really do appreciate it. And if you're listening, go check out that podcast. So on the other side of water treatment, we have at Insight Partners a Recon group, which is a reconstruction of cooling tower group. And I have Justin Lynch and Clint Burns here. How you guys doing today?
Doing great. How about you, Tony?
Doing good.
Good. Hey, Justin, why don't you, for the both of you, give people a rundown of kind of what you guys do for cooling towers?
So at Insight, we are reconstruction specialists. So our job is to go out and inspect cooling towers for needed service, repairs, and anything a customer has or questions they have about their equipment. We're here to answer that.
Well, I thought cooling towers were plug and play. You just plug them in and you're done. What are you talking about?
That's it. Yeah, that's all you do. Once they're installed, a lot goes in thereafter. So your service is going to depend on the location, use, tower design. There's a lot of different factors. So we're here to help customers understand what's needed and where to go from point of install forward.
All right. So thanks, Justin, for that rundown. More to follow. We'll be double clicking on a lot of those things. So Trace, let's start with water treatment. So here's my experience with water treatment. I currently live in the mountains in Asheville. I used to live in Florida, and I had a pool. And just as bad, I bought this house, and the guy was like a fountain guy. He had this big, huge 10-foot wide water fountain, or what do you call it? I don't know, water feature or something like that in the lawn. I could not for the life of me keep that thing without being moldy and mildewy and algae and buggy. I mean, it was like a chemistry set. I had all this stuff. So one day when my wife was out of town, I put it on eBay or on what was that? Craigslist or whatever it was. Anyway, someone came and got it. It was like the best day of my life. So my experience with water treatment is a pain in the butt. And I can't even imagine like for cooling tower. So anyway, so just like for me, because I'm not sure when we say water treatment, I'm not sure exactly what that means. In our business, we do a lot of water cleaning, water filtration, but I think the water treatment has to do with the chemicals and that side of it. So give us the water treatment 101.
I love that setup, by the way, because I think everybody's had a similar experience with whatever they're using. Water feature, yeah. So anyway, water treatment is that thing that everybody knows they need, but very few people really know what it is that they're supposed to have with that. But I check the box. Hey, I've got water treatment. Is the guy doing a good job? Am I doing the things I'm supposed to do? Don't really know. So hopefully in today's podcast, we can clear that up. I like to explain water treatment as if everybody can put in their mind's eye a four-legged stool. And if we were going to stand on a four-legged stool, all four of those equally distributed legs would have to be nice, sturdy, and secure in order for us to stand on that.
Mm.
And that is the picture that I want everybody to have when we talk about water treatment. And now let's say I'm standing on that stool and I'm going to represent good, solid water treatment. In order for me to be good and solid, I don't want to fall off of that stool. So each one of those legs need to be sturdy. We're going to identify each one of those legs. The
I love it.
first leg is corrosion. So water's the universal solvent. So water, given enough time, will dissolve everything. That's what its job is. We tend not to like it when it dissolves our cooling towers and chillers. So we want to make sure that we slow down corrosion. We can't stop corrosion. That's impossible, but we can severely slow it down. So the first leg is we've got to do something for corrosion. The next leg, and I'll describe this as scaling. If you've ever boiled a pot of water and you got on a phone call and you forgot about it and all the water boiled out and you had the chunky solids that were in the bottom of the pan, well, those were always in the water, but they were dissolved in the water. And when they come out of solution, we call that scale. Scale's not a good thing because it inhibits the capacity of the water to flow. It also makes it a lot harder to transfer heat through the water, through the equipment where we can transfer the heat out. And that's what this is all about, is heat transfer, by the way. So we've got to make sure that everything that's in the water stays dissolved in the water. So that second leg is making sure that we don't have anything scale. The fourth leg is what you mentioned, Tony, all the bugs and stuff that are growing in your fountain. Well, they also grow in anything we have water in. So that's our microbiological fouling. We've got to keep those things at bay. And then our last leg is just general dirt and debris. Dirt and debris is coming in either inside the cooling tower via the fan and all the things that are there, or it's even getting brought in with the city makeup water. Those are the four things that we have to treat for. And whether we're using chemistry, non-chemistry, positive language, whatever it is that we're using to treat this cooling tower, we've got to make sure that we cover each one of those legs.
Excellent. I love the legs. So maybe we can go back and forth. You talk about the corrosion, then we ask the experts, what do you typically see corroded first? So maybe I'll pitch it to Justin from a corrosion standpoint. Maybe we'll hit each of these legs separately: corrosion, scaling, microbio, and then the dirt and debris. So I think that's a good format to this talk here. So corrosion, right? You got to the cooling tower. What is it you typically see or look for? Or let me back up. Why are you typically getting a call in the first place? And then you could lead that into corrosion.
With a tower and age, typically the older the tower, the worse condition it's going to be in. So most of the often, it's customers saying, hey, my tower is 10 or 15 years old. I need some type of service. Depending upon the tower construction, if it's stainless steel, you don't see a lot of corrosion. The interior mechanical equipment might be ferrous metal, so it's going to rust, and that's where you see your corrosion. But from the outside, the tower looks great. On a galvanized tower, we'll see a lot of corrosion on casing panels. That's typically the first place that you see it. So it's rusting through where your heat transfer surface or wetted area meets the structural part of the tower. And immediately upon coming up to a tower, you can see how bad the corrosion is based upon its amount penetrated through the casing panels, or has it gone to the structural steel that's a heavier gauge metal. So within a 10-second view, you can look at corrosion and say, all right, this tower has either been mistreated for several years, or maybe at one point in time it got a lot of chemical treatment when it shouldn't have, and it's caused an irreversible condition, which most often can be fixed, but there is a point in time where your amount of corrosion cannot be resolved by just, let's say, replacing the components that have been damaged.
That's excellent. And I bet as long as you've been doing this, you can tell going 70 miles down a highway when you see one on the top of a building, you can tell like what the water treatment's like just by looking at it, probably,
Oh
right?
yeah, you can see all the victims. Yep.
All the victims. So you mentioned construction materials. So Clint, stainless steel basin, I think is pretty common. You tell me yes or no, and then casing, not as common. And then what do you recommend? What do you recommend to an owner who may be in the mountains and not near the ocean in terms of the casing?
Well, casing and basins, stainless is going to be your longest lasting cooling tower construction material. We run across when you end up having monetary issues with they value engineer something out so they can save some money. Instead of going with an all stainless tower, they might get just stainless hot and cold water basins, or they go with an all galvanized tower, which then you have galvanized hot water basins and cold water basins and casing, structure, everything. So a lot of times now our recommendation is at a bare minimum is to go with stainless hot and cold water basins. If not, going all stainless, because the tower can be rebuilt year or time and time again with an all stainless without having to replace casing panels or basins or anything like that, the structural components of the cooling tower. So at minimum would be the stainless basins is what we would recommend. And we're in the business of fixing cooling towers. So galvanized cooling towers are our friend because they end up needing more repairs than the stainless. But our recommendation to our customers is, hey, if you have it in your budget that you can go with an all stainless tower, we're not going to be having a lot of the conversations we're currently having because you have a galvanized cooling tower.
Very good. I love it. And I know as a sales rep, I would always, at a minimum, stainless steel basins, right? It makes total sense. If you could afford it and it works, stainless steel. Okay, so we talked about one of the legs, corrosion. We talked about what happens, on the tower in terms of the materials. How do we prevent the corrosion issue? Trace, is that okay to break these legs up independently in terms of
I love it. I think
solution?
that's great. So again, it's important to realize that water is the universal solvent. So we're not going to stop corrosion. We can only slow that down. And the best way to do that is to monitor it. So if you have a cooling tower, and you should have some sort of device called a corrosion coupon rack. And what we do is we put little slips of metal in a bypass stream so we can actually see what the effects of the system and the program are having on pre-weighed slips of metal. And that's a preemptive view on what's actually taking place with the equipment. So rather than Justin calling me and saying, hey, there's a hole in the bottom of the basin, I can actually, on a 90-day basis, or depending on what type of equipment, maybe even every so many minute basis, look and say, hey, I think we've got a problem here. We need to make some changes. Let's work together and figure out what these are. And then depending on the water chemistry itself, there's a plethora of different corrosion inhibitors that we use. And I guess the one thing I'll say about that is don't ever assume that water treatment is one size fits all. I've got a building that is right across the street from another building in downtown Atlanta, different water supplies. So they are treated totally different, but I can be on the top of the roof and I can throw something at the cooling tower on the other building. So proximity does not matter. It matters how it's being used, what the equipment is, and what the water source is.
Interesting. So the first step is to see what you got, collect some data. This is where we're at in terms of the water chemistry. And then to put a plan together specific to that water chemistry to get it up to where it's supposed to be.
Absolutely.
Right. And water naturally is corrosive. It doesn't need any help to be corrosive. Is that correct? Like,
yeah, if you want to have
doesn't need
some
to be
fun,
bad water. It could be fresh spring water. It doesn't matter.
Well, here's the thing. The more stuff that's dissolved in the water, the less aggressive the water can be. But water is the universal solvent. So given enough, it might take it a little longer to dissolve what it's dissolving, but it will dissolve it. If you want to have some fun at home tonight, put a nail in a glass of water and just watch it over the next week. And after a couple days, it's almost going to be gone.
Wow. Galvanized nail, I'm assuming.
So galvanizing,
Or
yeah,
steel.
So just plain steel would actually get the job done. But galvanizing, we're actually corroding the galvanizing to protect what's underneath the metal, which is the steel. And then once that galvanizing is gone, we have a tremendous corrosion issue wherever that galvanizing is missing. So if you have a galvanized tower, it's important to take care of that as soon as it sees water. I know we come in a lot of times and the tower's been on for a while. It's a brand new tower. Well, it needs to be properly passivated is the term that we use. And we actually have to impregnate that new galvanizing with certain ions to make sure that it's set up properly and it can survive as long as we hope it will with that tower.
Justin, how many towers are passivated properly in your experience?
The vast majority are not passivated properly.
They're not passivated, because I remember the only reason that clicked in me, because we were fortunate enough, Justin and I were fortunate enough to be on Trace's podcast a few weeks ago, and we talked about this, and I'm like, this is like, I've been in the industry for 25 years, so I'm like actually learning stuff as I go here, but like, Justin, why does it not happen? Where's the communication breakdown? Because I'm sure the tower folks want that to happen, and the tower experts want that to happen. What's going on? What's the breakdown?
When an owner gets a tower, it's not always directly purchased from the manufacturer. It goes through rep firm channels, could go through engineering, contractors, and paperwork is given to whoever purchased the tower. So that very important bit of paperwork is buried, let's say, deep in a large packet. They may not even read it. They may not see it. Most people don't read instruction manuals when they get them. They understand, like you said, you just turn it on, let it run. And unfortunately, that's what happens. It is common for us, at least, that passivation is required, and we try to share that with owners. And sometimes it's needed again. There are certain cases where you can repassivate to continue to try and protect that galvanizing that's there. But most often, I don't think that whoever is going to be operating the tower in the end was able to see the instruction that came from the manufacturer. There's just a gap there that needs to be bridged. So that's why we try to do our best to try and share, hey, passivate when needed, chemical treatment immediately upon tower install. That way you can prolong the life of your tower as much as possible.
So a lot of engineers listen to this. Is that something that is in their spec and gets ignored, or maybe they should put that in their spec? What are your thoughts on that?
I think it's in the spec.
It just doesn't get adhered to.
I don't think it gets adhered to, and it's something that's easily checked off. And if you read, Marley in particular has a set of standards to passivate. But I know for a fact that passivation can be done in different ways. And like Trace was saying, not all water sources are equal. So I believe sometimes a different method is going to be needed. And it's more so hey, this isn't a one-day passivate. It needs to be a prolonged ordeal. And oftentimes it's just, hey, tower's running. We need to get the process up and running, or this building needs some cool temperatures. Let it go. And that's unfortunately what happens.
Gotcha. And the passivation is done by the water treatment folks, Trace, is that correct? It is a chemical.
Yeah, it's a chemical, but it's also working with the on-site team there. So we look at all the things that are going to increase corrosion, and heat is one of those things. So if we can actually do this process offline without the introduction of heat, we're going to have a much easier time and a better passivation process if we can do that. I know sometimes that's just not possible. We've had situations where they've been able to makeshift set up the cooling tower, allow us to do something for ideally 8 weeks is what it takes to set something like this up. Again, it really matters with your water treatment program, what's coming in. And that's why it's important that people get together and talk. And who's going to be involved in this? Okay, well, we have the people that are supplying the equipment. We have the people that own the equipment, that are going to run the equipment. We have the water treater and anybody else that I forgot out of that mix. We all need to come together and say, okay, it's not just putting this tower on the roof. It's making sure it's operated properly. It's making sure that we get the longevity that the owner is hoping to get out of this. Now, how do we all put our input in to make sure that that's our goal?
Yeah, because I'm thinking like most of the time the water treatment guy is not around at startup. Not
I can't
involved
tell
at
you
that
how
point.
many times, Tony, that I've serviced an account and I'm like, that's a brand new cooling tower. I wasn't expecting that.
So it's so rare. It's a shock to the water treatment guy who's like, oh, I got on here early. This is nice.
So
getting
hopefully
on
it's
there.
not after this podcast.
That's right. So, right. Well, we don't want you to do too good of a job, Trace, because we don't want to take business from Clint and Justin because they gotta feed their kids and everything. But no, just kidding. But so like it's rare that there's water treatment in general, and it's even more rare that you're there from the beginning, and then it's even more rare that you get the 8 weeks without heat. I'm sure. I'm sure that's probably pretty rare. Fair statement.
Fair statement.
Okay. Got it. So can't we all get along was popping in my head. Like we need to do a better job of, I think it is one of those things that's just not thought of very much. Like just the general maintenance, we were talking to, I don't know who I was talking to this about, but it's like just when you look at like the ROI as a business, as a corporation, changing your filters, keeping your coil clean, keeping your towers clean, keeping your tubes and your chiller clean, the ROI on that is huge, especially when you look at the longevity of the equipment. You're talking about $500,000, retrofit in 15 years versus 20 years. That's a major ROI. And it's just not, I don't think it's looked at. It's not as flashy as investing in whatever you're going to invest in. I don't know, new computers or solar panels or something, which are good too. But it's like, before you do all that, let's take care of the stuff you got. It reminds me of like when I wanted to upgrade my home to a VRF system in Florida, because I was all in efficiency and we're going to make it water cooled and ground. So, and it was so expensive. The guy's like, dude, get new windows and insulate your roof. Like that's what you need to do. Right. Like, so it's kind of reminds me of that, but a little bit off topic, but the importance of, taking care of what you got. Not only is it good for the equipment, but it's good for the bottom line of the business. Okay. So that was leg one. You guys feel free to go back to that at any point. That was the corrosion part. So scaling, I see some scaling behind Justin there. So Justin, why don't you, Trace, give us another rundown. So scaling, I get it. Like when you boil off the water, the dissolved solids are what's left and they stick to things. Is that a good summary or?
Well, so that would be, I'll tell you, let me talk about the picture that's behind Justin. I know it's this podcast, so people can't see that, but what we're looking at is a mineral scale on the outside of the tower fill material. That is actually not scale. That is evaporative salt. So only pure water evaporates, leaving its solids behind. And what we have in a cooling tower is a very concentrated water that is now getting flicked out to the outside of the tower fill, and it's evaporating away, leaving its minerals, its solids behind. And that's what we're seeing. Not necessarily scale. It is a problem because it can impede airflow and it should be cleaned off. But that is not tied to water treatment because the only thing water treatment can do is treat what is wetted 100% of the time. And that's an evaporative salt on the outside. So it's not wetted 100% of the time. Now let's talk about the material that's wetted 100% of the time. So we're going to peel back that tower fill, look inside. Now, if we start seeing scale there, that now is an issue because something that has not evaporated fully has come out of solution. And now we've got to figure out why is that. Now, maybe we're concentrating up too high. And if you've ever seen a cooling tower water treatment program, it involves a bleed. So normally we measure conductivity. Conductivity is how many solids are in the system. And once it reaches a specific conductivity, it opens up a bleed valve. It bleeds out that high solids water in the cooling tower and replenishes it with very low solids water from the makeup. So we might, in Atlanta, we might be concentrated 10 times. Well, so we're releasing 10 times concentrated water. We're replacing that with 1 times concentrated water. My dad used to say the solution to pollution is dilution. What we're doing is we're diluting the water, and that's how we're doing solids control. I'm sure there's people that listen to this podcast that have experienced, oh no, I'm wasting water. I need to close that bleed valve. Please don't do that, because that's going to cause a scaling situation. And keep in mind, I said here in Atlanta, we can concentrate that up 10 times. So we're saving water 10 times in that cooling tower. So all those calculations go into what's the water coming into the system, how much we can hold based on the chemistries that we're using, and then also what are the dynamics of the system? How hot does the system get? How is the system being used? What are some of the other legs that are going to play an effect with scaling? And that's the thing. It's not just one leg by itself. They all tie together. So a competent water treatment professional would look at all of those pieces and make sure that that tower is being treated properly.
And who does the concentration measurement and the bleed? That's the water treatment folks.
Yes, that normally takes place with water treatment. So if you and I were doing business and we hadn't met before, I would survey so I could get all the information to all these questions that I would have, like I just mentioned. Also, I'd ask you a lot of questions about how you operate it, and also what are you willing to do in between times that either myself or my team is on site. And then based on all of those answers, we're then going to try to figure out what the best program is. And we'll set up all those things that I just mentioned.
Excellent. So Clint, what's your experience with, how often do you see the proper concentrations being monitored and maintained? And then what are the results from a mechanical standpoint on the tower? What does the fill look like, et cetera?
So we really say we're not chemical experts. We want you to rely on your chemical treatment expert to make sure your water is within the guidelines set forth by the factory. And Marley actually has water quality guidelines that you're supposed to follow. So we don't get into the nitty gritty of the chemical treatment professional, but we do ask questions like, hey, your makeup valve is always putting water in the tower. Are you blowing down? Do you know how many cycles of concentration you're running? Things like that, to where we can just kind of scratch the surface to make sure, hey, yeah, they are doing the things, checking those boxes, but we don't get into the nitty gritty just because we're not chemical experts or chemical treatment water experts.
Stay in your lane came to my mind, right?
Exactly.
I need to learn. I need to remember that one. That's a good one.
I know, and when you get myself in trouble, but that's about it.
That's another one. My wife, I hear that. Stay in your lane. I don't know. This might turn into an interesting podcast when we drop it. But so the cooling tower, they're not taking care of it properly. And let's talk about the fill. And I'm gonna put a little plug in for, if you want to see videos on this, there's videos on insightUSA.com on the recon page specifically. I was fortunate enough to go out to a job site with Clint and Justin, spend a week out there, and there's tons of videos of actually ripping out the old fill. We show you what it looks like when it's, really degraded, and it just basically it's brittle. It like crumbles in your hand, and what it looks like to replace that. So if you want to get more education on that, you can. So this is news to me. I thought when the fill got dirty, you can go out there with a pressure washer and clean it. Clint, what do you recommend? Do you recommend that or no?
We do not want to see high pressure water on fill material. As Trace was saying earlier, those salts that are dissolved or on the outside of the fill, the louver face of the cooling tower, really don't impact performance unless it blocks airflow. And we tell that to customers all the time. It's like, yeah, the fill, it looks bad, but the tower's functioning correctly. Unless you're impeding airflow, yeah, you want to get it, you want to rinse it off if you can, but you're not going to go up there with a power washer and send your junior guy out there and just say, hey, go clean it. Because as soon as he does that, it's going to be cut up. It's going to start getting even those little pieces of fill breaking off, getting in your strainers and your chillers, all that kind of stuff. So we actually do not use a power washer to clean fill when we go out to clean a cooling tower. We want to basically rinse it down. If you have a lot of buildup on the outside, you can take a soft bristle brush and try and get some of the bigger pieces to fall off. But we want to not damage the equipment when cleaning it.
Tony, if they talk with their water treatment provider, they should have a product that it's probably an acid-based product that they can spray on. Some of them have a foaming tendency to them, and that will break down some of the things that's allowing them to adhere to the surface, and then they can take a hose and just hose them down. This doesn't work with every single cooling tower, but an induced draft counterflow tower that has the kind of the doors all around the side, or the drift eliminators all the way around the side. I always try to get people that have those to buy an extra 1 or 2 of those and leave it in the tower basin. And then every month they just circulate those through. Our products, they'll take care of all of those evaporative salts, and then that can just be part of your regular maintenance program.
Very good. I love it. Justin, anything about the salts, the scaling you want to, throw some wisdom out there for the audience? I know you got some.
It is always a big concern, and that's a lot of times what we get a call for. When you asked earlier, what do you see on a tower? You see, customers call it scaling, and it is evaporative salts, and it's not a big concern. For us, it is pressure washing. We don't pressure wash the media. We will clean a tower inside with a pressure washer. But the problem with like what Trace was talking about, the air inlet louvers and things like that, and having one put in the tower and cycled around, a lot of people just don't have the ability or the time to do that, and makes it really difficult. The biggest thing we can push is it's cosmetic. So unless you are losing tower performance, just don't stress it. A lot of people say, well, it's in the view of the public and we don't like it. If you want to use the acid to clean it, that's a question that we get asked. What should we use? And we can't tell you, because we don't know what your tower is serving. Is it serving, just going straight to a heat exchanger where it's not really going to be a big deal? Or is it serving process equipment? So for us, we don't want to use any type of acidic solution to clean that off, because we're not sure what it's going to injure downstream. So we always try to defer that, at your own risk, please use it, but always consult with your water treatment specialist, because they know the makeup of your water and what adding, X chemical could do to the makeup and the quality.
Nice. And now you could say, there's this guy, Trace Blackmore. I don't know if he's any good, but he was on our podcast. Maybe you can, no, I'm just kidding. So now you got a reference for Trace. So excellent. I see some opportunities coming together in the future to help serve our clients. So this is good stuff. Okay, leg number 3. So we talked about corrosion, scaling. What about microbiology? So can you dip into that a little bit, Trace, and then the guys can give their 2 cents on what they see in the field?
Yeah, I've got to say, of all of the legs, this is the hardest one to treat, because these microbes, their job is to eat and reproduce. And whatever we throw at them, they've got all day long to figure out how to overcome that. You mentioned a couple with your water feature, but if we have our sunlight that's getting...
I'm bringing back getting nightmares just thinking about it. It was
it was a great setup. I loved it. I think everybody had the visual. But if you have a tower where it's open to the side, then you're going to see algae. If it's closed off, you're probably not going to see algae, but you're going to see fungus, yeast, molds, and bacteria. And some of these bacteria actually can be pathogenic, which means it can make you sick. And the L word is Legionella, and we can do an entire show. And a matter of fact, I'm going to offer, maybe I can come back and we can talk about Legionella. Sure. But I want to separate Legionella from this leg. Yes, it is biological, but when we're talking about all of the things that the legs do, it's about equipment and longevity. It's about heat transfer efficiency. Once we add a health component to it, that's an extra bolt-on that needs to happen with the water treatment professional, with the people that own the cooling tower, to make sure that everybody's doing their part. Because it's not just something the water treater can do. It's not just something the building owner can do. There are a lot of things that have to happen, and they should happen. Everybody should be dealing with that. But to just say, oh, I've got water treatment, anything I have to worry about around Legionella is covered, that's not a correct statement. And again, we can take an entire show to talk about that. I'm just going to leave it at that and realize that your listeners, if they have a cooling tower, they need to be doing something about Legionella, and they are not doing something about it if they just think I have a water treatment program and that's taking care of it. So Legionella aside, the things that we are looking for, all the things that are going to grow in the system, that are going to grow on the side of the heat transfer areas and not allow efficient heat transfer. It also might impede the water that actually goes through. We don't get as much water that's going through. And I've seen some systems that were so badly fouled, there was no heat transfer at all going through. The interesting thing about the legs is that each one of the legs affects the other leg. So if I've got something growing on a pipe, I just created a corrosion cell because I've got a different underneath what's growing on the pipe to what's on the outside of the pipe. I've also created a spot, and here's my fancy word for nucleation. Nucleation is the first seed crystal where we start to scale. So we've got to make sure we're taking care of all of those items, or one of those items is going to affect, or one of the legs rather, is going to affect the other leg. So we use microbicides in order to basically kill the items that are in the system. And there's also testing for that. Now, in a cooling tower, we don't look for a sterile environment. We look to keep it at a certain area and make sure it doesn't grow any more than that. So I would encourage everybody to speak with their water treatment professional, make sure that the right biocides are being used, and ask the question, how do I know? How do you know that the right biocides are being used? And what are you doing to test that? And then what's the benefit of those tests? And that's a great conversation to have with your water treater.
Excellent. And thanks for separating the Legionellas from, it sounds like that's a deeper dive, a bigger buy-in. Like, look, if this is what you want to be assured of not having, we got to have a conversation that involves more than just me. Is that accurate? Okay, got it. Justin, microbes, microbiology. Am I saying that right? Microbes, stuff that grows in the tower.
It is a common issue, and what Trace was saying, where if you affect one leg, it affects the other. We see it as a constant balance between your scaling and corrosion and your algae growth is a lot of what we see in towers. In the plenum area on the inside, so if you walk into a cross-flow tower, you'll see it up around the mechanical equipment, on the insides, on your drift eliminators. A lot of times it is thick, it holds water, and then that also causes excess drift because the water is allowed to stick there, especially when you get a warm heat load in the tower on a cool day. You'll see a lot of that and steam coming out. Algae is an issue, and normally when customers do see that, their biggest concern is the L word, Legionnaires, which again, a whole nother conversation, but most oftentimes we see that Legionnaires is not a concern because it is being taken care of. Now, when you have the biological growth and it scares people, what we see is an overdosing of chemical. And it's just a reactionary. If a customer ever had an issue previously, they tend to overdose their towers, which causes more corrosion. So we have some customers, every couple of years, we're doing repairs that shouldn't be done, but every 10 to 15 years. And that's because they are putting too much chemical in their tower, causing corrosion, which I would ask Trace, what chemicals do you see that cause the most corrosion? And are there some limits that should not be breached with those chemicals? Every tower I know is its own scenario. No solution is going to work for all, but that whenever there's green in the tower, there's typically more bromine or chlorine, whatever the case may be. And then subsequently, a year later, we see rusted out basins.
It's a great question, and you set it up very well. It depends on the system. So again, there's no one size fits all in industrial water treatment. You mentioned bromine and chlorine. So the chemistry term for that are halogens. So when we're using halogens, those are probably the most effective biocides out there because of how they kill. There's some other ones that we can mention, but I think we all get the gist of it. One of the issues with using them is that they can increase corrosion. So if a gallon's good, well, hey, 10's got to be better, right? Well, there's always no free lunch in anything that we're doing here. So we have to, yes, it's going to absolutely kill everything in that system, but we're also going to take away some of the life of that system. So probably not the best idea to do that. So understanding which product you're working with, what you want that product to do, and then also what equipment that product's going to be in are a must before anything's applied.
My pool is now coming to mind because I would get this brown algae and I would try to overcompensate. I can't remember what I overcompensated with, whether it was acid or chlorine or whatever, but then it would throw this other thing out of whack. And then I would try to do that. And it was just like this never ending. But I mean, for a tower, aren't you guys overthinking it? Can't you just go to Walmart and get those floaty pool things with the chlorine tablets and put them in there? Clint, isn't that your favorite go-to for cooling towers?
Of course. I just love it when I go to a cooling tower and there's a floating pool chlorine basket in there. It happens more times than not. So much so that people are like, oh, well, I have a stainless basin. It's fine. It's like, well, no, it's still so concentrated in that one corner where that thing is floating that it'll burn a hole right through the stainless. I've seen it happen before. So we don't like seeing the floating pool baskets in cooling towers. But like I said, I'm not a chemical expert, and maybe there's a rhyme and a reason for where that would be a good idea.
Right.
But more times than not, we end up seeing highly corrosive metal in the area where that basket was.
Gotcha. Makes sense. Yeah. So another example of stay in your lane. If you're running a running a chiller plant, call the professionals, and even in this call, I'll be glad to help. So we're going to move into the dirt and debris, which is great. I'm going to ask Clint because he's got a dirt and debris remover behind him in this podcast here. We'll see if we're going to put this up on the YouTube channel. You can go see it there. You can see some of those again on the website I referenced earlier. But Clint, talk a little bit about what that contraption is behind you and what you typically see. What do you recommend? When I was out at the one you guys were rebuilding, you were putting in sweeper piping, and I'm asking you like 50 questions at once here, but you can just touch on whatever. Sweeper piping, and there was a bunch of accumulated dirt and debris in the bottom of the tower. So what do you typically see? What do you recommend?
So this particular customer with the picture that's behind me, they had a lot of dirt and debris that was getting into their system, so much so that it was clogging their chillers up, because they would basically go in line, and their number one chiller, they had to clean it like 4 times a year because they were getting so much junk in their system. So when it was time for a rebuild of the cooling tower, they had a lot of rust and corrosion going on in the casing. It was several years of planning, budgeting, all that. And they said, well, what is our option for trying to get all this junk out of the tower? I mean, we can't take our process down because this is a manufacturing plant. They're like, we can't take our process down 3, 4, 5 times a year to clean the cooling towers, and we have to run everything all the time. So we came up with adding the sweeper piping to the cold water basins and adding a filter system that would then help filter out all those solids that are in the water. And they have the cleanest water they've ever had, and they are just tickled to death about it. Because before you'd open the door, you couldn't see the bottom of the cooling tower because there was so much just junk in the water. And now you go to it, it's crystal clear. Their chemical guy loves it because it makes his job easier because he's not fighting 2 inches of mud on the bottom of the tower because it's staying clean. So just one aspect of what we're seeing more so prevalent now is people adding filter systems, sweeper pipings with even new installs. And even if you don't add the filter system, put in the sweeper piping in your new cooling tower that you can add a filter system at a later date if you don't have it in the budget at that time. But we're doing more and more retrofits to add sweeper piping, even if they don't do the filter. So they can add it later just to try and help keep their water as clean as possible. Because, I mean, we preach to our customers, water chemistry, water quality, and cleanliness of the tower are what make it last the longest. and getting all those things in line and the correct cleanliness, the correct chemistry, it's going to give you the longest lasting piece of equipment.
And I keep going back to the ROI, right? Like why, from a business standpoint, it just makes perfect sense, especially in that scenario where you're cleaning the tubes, 4 times a year. That's a major deal to do that. How was the dirt getting into the tower? Was it just in a dirty area or?
Is right off the highway. There's woods around, and I think there was another plant not too far away that created a lot of dust. And the cooling tower is just the biggest air scrubber in the world. Anything in the air, it's going to pull it right in the cooling tower. It's going to get in the water. It's going to settle out in the bottom of the tower, and then you have to deal with it, even though your neighbor's the one making all the dust.
Perfectly engineered air cleaner, that's for sure.
Exactly.
Justin, what is sweeper piping for those who don't understand?
It's a network of plumbing in the cold water basin of a cooling tower that circulates from an external pump, so it doesn't use any pump for process or HVAC. It's going to pull water from the basin, it's going to filter it, and it's going to go back to that piping through jets. It's going to agitate whatever dirt and debris is settled in the bottom and force it to the lowest area of the cold water basin. We call it the depressed area or the sump. And then it's going to suck it back into that filtration unit, and it's going to just continue on and on and on. And you can set it up for, like, that system is a 4-cell. You can have one filtration system run all 4 cells at the same time, or you can cycle it through. But as long as, if you've got sweeper piping in and water's moving through those jets, in theory, no sediment should settle in the basin, and it should be moved out. Now, the sweeper piping is an awesome addition to eliminate downtime in a cooling tower and reduce the time it takes to maintain. However, it is not an end all to mechanically cleaning a cooling tower. You should always clean your cooling tower and get in it at least once a year. Even if you've got a really clean tower, get in there, give it a once over. Some facilities are so dirty, even with sweeper piping, they might need cleaning twice a year or even quarterly. It just depends upon your environment.
Great explanation. And just to delineate the two, water treatment and then filtration, 2 separate things, right? Trace, why don't you go out on that note and give a little explanation of that?
I love the setup again. So with that, this is the one leg that requires some sort of mechanical filtration. Now everything else we speaking are some sort of chemistries, most likely. We can put a chemistry in to keep things fluid and flowing, but it's got to go somewhere. Where's it going to go? Well, it's going to go in that chiller or that heat exchanger that you guys were just talking about, or we actually put some sort of mechanical filtration. So it's my hope that someday cooling towers aren't sold without filters, but that's not the world we live in right now. But really, I can't do my job unless there's some sort of filtration on that cooling tower.
Other than the cooling tower.
Other than the cooling tower, correct.
Air scrubber. All right, let's wrap this up. I think we got some good information here for the listeners. Hopefully, I know I learned a lot, as I always do in these. But Trace, why don't you talk a little bit about your podcast? Anything you want to talk about where people can go and get some value and learn some more about water treatment or anything you got coming up?
Yeah, I appreciate the offer. So it's called Scaling Up H2O, and that is anywhere you consume podcast content. My staff's done a great job of making sure that we are on every platform. So do me a favor, if you find one we're not, let me know about that. But we talk about everything industrial water treatment. And if you're kind of curious, what's the water treatment perspective on filtration? I guarantee you will find at least a few shows on that. If you go to scalinguph2o.com, we do a transcript of everything. So if you do a search, you're most likely going to find anything that you need. And I know we didn't talk a lot about Legionella. I assure you, on the Scaling Up H2O podcast, there is a ton of Legionella content. In fact, we have a special page dedicated to Legionella. Again, if you go to scalinguph2o.com, go over to our resources page, and you will see there's a Legionella tab there. It has everything that we've collected on the show over the past 7 years. And each and every August, we dedicate the entire month of August to Legionella awareness. So there are just a ton of episodes out there on that.
Excellent. Thank you so much. Justin, talk a little bit about where you work and how people can get a hold of you. And I just think you might have a free tower inspection offer.
Could be. So both Clint and I are reconstruction specialists with Insight Partners. Our job is to go out, inspect cooling towers. We might provide service for PMs, rebuilds, maintenance. We do anything and everything cooling towers. So you can find us at Insight Partners website under the Recon tab. Feel free to give us a call. We are happy to come out and inspect your cooling tower free of charge. And it doesn't matter the make and model. We're happy to look at all of them because we have our in-house service crew that does work on every make and model.
Excellent. So anywhere in the Carolinas, all things cooling towers, parts, recon, free inspection, insightUSA.com on the Recon tab. And if you're listening, I'll put that in the show notes and you can go and contact, you can get on the website and fill out a form, or you can contact Justin and Clint. Their numbers on there direct because they eat, sleep, and breathe cooling towers. So just call them any time of the night, right? You don't care.
That's right. Phone's
you get right in your
always
truck. That's right. And you could, of course, I'll put your information in the show notes too. So yeah. So Trace, thank you so much for being here. We appreciate you.
My pleasure. Thanks for having me.
Awesome. Clint, Justin, thank you so much for being here. Hope you'll come back.
Thank you for having us.
Yeah, thank you for having us. I do have one question for Trace before we just wrap up.
Absolutely.
Something just kind of popped into my head. We have a lot of customers that have multi-cell cooling towers, and they run it from a standpoint of a lead lag, whereas we try and talk to them about variable flow over towers to use all your heat transfer surface. And I think that kind of comes into, you want the water moving in the cooling tower as much as possible so the chemicals can do what they're supposed to do. Is that an accurate statement?
That is a very accurate statement. If we don't have flow, we cannot treat it.
So stagnant water is your enemy.
Absolutely.
And the cooling tower's enemy.
So we can talk about cooling towers. We can also talk about other pieces of equipment that for efficiency, it will close off the flow. And for an efficiency standpoint, that makes great sense. But for a treatment, a longevity standpoint, it just can't exist that way. So yes, I love that you brought that up. We have to have flow or we do not have good water treatment.
Sounds good. Thank you.
Again, the fountain popped in my head. When that pump went out, the clock was ticking in Florida in the summer. You had like a few days, that thing was filled with algae. Anyway, great way to close it. Thank you guys for being here. Thank you so much for listening to the Engineers HVAC Podcast. Please come check out our YouTube channel at HVAC-TV on YouTube. And we thank you so much.